Question 6. A. Find the distance x in the diagram which is not drawn to scale. Give your answer correct to 2 decimal places. So let's have a look at the triangle we're given. We know 2 of the angles, 65 degrees and 63 degrees. One of the sides is labelled as being 10 centimetres long, and another of the sides is labelled as x. This is what we must find. There's a useful fact about triangles which says that the 3 angles in a triangle must always add up to 180 degrees. This means that whenever you have 2 angles in a triangle, it's quite easy to find the third angle. It's simply the leftovers needed to make sure all the angles add to 180. Here, 65 plus 63 is 128. The third angle is the leftovers needed to make this sum into 180. To find it, we can do 180 minus 128, which is 52. Even though we weren't asked to find this angle directly, the more information we know about the triangle, the easier it's going to be to find x. So, let's focus on finding x. Our triangle is not right-angled. In this situation, there's 2 main options for finding unknowns: the sine rule or the cosine rule. To determine which of these to use, it's helpful to think about the number of sides and the number of angles that we are concerned with. The sine rule involves 2 sides and 2 angles. The cosine rule involves 3 sides and 1 angle. Notably, the cosine rule involves all 3 sides. In our triangle, we only have 2 sides labelled. This rules out the cosine rule, so here we'll want to use the sine rule. This rule can be found on page 16 of the formula book. It says that given any 2 side plus angle pairs, little a capital A and little b capital B, we will have little a over sine of capital A equals little b over sine of capital B. The convention here is that we use capital letters to denote angles and the lowercase equivalent for the side opposite that angle. So here, capital A is an angle and lowercase a is the side opposite that angle. Capital B is a different angle and lowercase b is the side opposite that angle. So let's look at the triangle we were given. The key to using the sine rule is thinking about pairs of an angle and the side opposite it. To use our sine rule, we need 2 of these pairs. For the first pair, we can take the 63-degree angle and the 10 centimetre side opposite this angle. I'll label these with capital A and lowercase a. For the second side angle pair, I'll take the 52-degree angle and the side labelled x opposite this. I'll label the angle with capital B and the side with lowercase b. We are now ready to sub in to the sine rule. Our goal here is to solve for x. In other words, to isolate x all by itself on one side of the equation. To do this, we'll need to remove the sign 52. A fraction represents division. X over sine of 52 is the same thing as x divided by sine of 52. The inverse of division is multiplication, so to remove division of sine 52, I should multiply both sides by sine 52. From here, it's a matter of doing some calculator work and some rounding. Rounded to 2 decimal places, we found that x is equal to 8.84. X represents a side length and the unit here is centimetres. So our final answer is that x is equal to 8.84 centimetres. Part B. Find the distance y in the diagram, which is not drawn to scale. Give your answer correct to 2 decimal places. In the triangle we're given, one of the angles is labelled as 53.8 degrees. One side is labelled as 10.2 centimetres, another side is labelled as 8.5 centimetres, and the final side is labelled as y. Similar to part A, this is not a right angle triangle. And there's 2 main options for finding unknowns in this situation: the sine rule or the cosine rule. To determine which of these to use, it's useful to think about the number of sides and the number of angles involved. The sine rule involves 2 sides and 2 angles. The cosine rule involves 3 sides and 1 angle. If we look at the labels on our triangle, we have labels on all 3 sides and on 1 angle. So here, using the cosine rule will be a good idea. This rule can be found on page 16 of the formula book. It says that given 3 sides, A, B, C, and the angle capital A squared is equal to b squared plus c squared minus 2bc times the cosine of capital A. As before, the labelling convention is to use capital letters for angles and the lowercase equivalent for the side opposite that angle. When using the cosine rule, it's crucial that the side labelled with a lowercase a is opposite the angle labelled with capital A. The labellings of B and C are less important. They play symmetric roles and can be assigned to the other 2 sides in either order. The cosine rule only involves 1 angle, capital A. In our triangle, we only know 1 angle, this 53.8 degrees. So let's label this with capital A. The side opposite this gets labelled with lowercase a. In our triangle, this is the unknown value y. The other 2 sides can be labelled with b and C in any order. Here I will let B be 10.2 and C be 8.5. From here, we can sub in to our cosine rule. The right-hand side here is quite messy, but we can simplify things a lot just by using our calculator. We found that y squared is equal to 73.879. To find what y is, we'll need to remove the square. The inverse of a square is a square root, so to remove a square, we should take the square root of both sides. From here, it's a matter of doing some calculator work and some rounding. Rounded to 2 decimal places, we found that y is equal to 8.60. Here, y represents a side length, and the unit here is centimetres. So our final answer is that y is equal to 8.60 centimetres.